Energy Research Institute for our Zero Carbon Australia project partners for the venue. So for people that haven't been to one of the discussion groups before, BZE is a climate solutions think tank and research organisation. Our goal is to transform Australia from a 19th century fossil fuel-based economy to a 21st century renewable powered clean tech economy. So our projects include the Zero Carbon Australia research, Repower Australia talks, media work, education programs and much more. And we're always looking for more volunteers, so come and talk to us afterwards if you want to get involved. So the discussion group is a forum for climate change solutions, and we have presentations by experts in the field, and it's held first Monday of every month, so it's good to see you here again. So tonight we're continuing from last month's topic on switching away from gas to electric. Energy Freedom is the new initiative from BZE. It's been up and running for over 6 months, and already over 1,000 Australian householders have pledged to transform their homes. Energy Freedom aims to support and educate Australian households on how they can retrofit and install technologies to make their homes zero net energy and remove fossil gas as an energy source. So Richard Keech is one of the principal researchers of the ZCA Buildings Plan, and tonight he's going to recap the key findings of the Buildings Plan as they apply to retrofitting homes, and also talk about how the Buildings Plan has been translated into a new book for homeowners. In the second half of the session, the manager of the Energy Freedom Initiative, James Bramwell, will be facilitating an extended Q&A with you. So, pass on to you, Richard.
Thank you, Jenny. Hi, everybody. It's a pleasure to be here again. We want you to talk about energy freedom. First, let's consider why energy freedom. It's to empower householders to radically reduce their energy consumption. And where does the idea of energy freedom come from? Well, it stems from the Zero Carbon Australia Buildings Plan, which was launched in late 2013. And I was lucky enough to be a contributor to that plan. In a big part, this idea of energy freedom challenges the idea of normal in terms of what I envisage as the normal householder. So I just tried to encapsulate this idea of a normal householder's attitude to energy by framing a couple of statements by a hypothetical normal householder. A normal householder might say, I can't do much about my energy consumption, or my energy bills are largely outside of my control. Energy is something I buy from a big company. I don't really care where my energy comes from. I'll wait till I renovate, or I'll wait till I buy to fix problem X. So, and lastly, of course I use gas. They're the sorts of things that a normal, hypothetical householder might say. So, what is energy freedom? I've tried to distill it down to 6 words. Net zero energy, no fossil fuels. I think that sums it up, but it may need some explanation. Net zero energy, hopefully most of you are comfortable with the idea, but let's just be clear. Okay? A house achieves net zero energy when its annual energy consumption equals its annual energy generation. So in that regard, solar PV is a game changer, because our hypothetical normal household doesn't generate any power. And until now, it might have seemed like achieving net zero was outside the realms of feasibility for most households. The other flip side of that definition of energy freedom is no fossil fuels, which largely means no gas. The gas myth is that it is cheap and that it is clean. In my research, I consider that the reality of gas is that it is not efficient, or not as efficient as it could be. It really does involve high end-to-end emissions, and that it is increasing in price. So the reality and the myth about the use of gas in homes are quite different. To a large part, embracing energy freedom is to look beyond conventional thinking. The benefits of which are that comfort goes up, costs go down, house value goes up, emissions go down, and the other side of the coin in looking beyond conventional thinking is that money spent in achieving energy freedom is an investment, not an expense. Investment, not a cost. So framing this in terms of a valuable investment like the same mindset you might apply to your superannuation or to investing in shares or investing in property. Investing in the value of the energy performance of your house is real and tangible. So what's the context in which we are principally applying energy freedom? Well, our main target audience is firstly for existing homes and principally for owner-occupiers. So that's not to say that these ideas don't have broader application, but we see the main target, the main potential for this approach to make a huge difference in this country is for those people who have their own home and can transform it radically. Okay, how to achieve it? The basic principles of applying energy freedom are, of course, energy efficiency, the adoption of renewable energy, and no fossil fuels. And that broadly we have split into 9 areas: insulation, windows, lighting, draft control, hot water, monitoring control, heating and cooling, cooking and appliances, and solar power. So each one of these could be a whole discussion or lecture in its own right. So in the time we have today, I'll just very, very briefly discuss some of the considerations that apply to each of these. And then we'll look at, again very briefly, how all these come together and improve the performance of a house. First of all, a caveat. BZE's discussion of all this shouldn't be interpreted as an invitation to do anything unsafe. As a DIY householder, safety comes first. If you're dealing with pipes and wires, use the pros and get professional advice. Okay. We've discussed 9 steps. The order is largely arbitrary, but not entirely. So consider these an order which you might approach it, but it's largely, it's very flexible in terms of the order that you might tackle this in your own house. Step 1, lighting. Broadly, we consider it important that householders replace any existing incandescent lights with LED lights. And this should be done preemptively because incandescent lights are very inefficient. This especially applies to halogen downlights. So halogen downlights are an incandescent light. And they may be low voltage in many situations, but that is not to be confused with low power. And there are other problems with downlights as well. Existing fluorescent lights should be replaced, but probably wait until they fail. The performance difference with LEDs over fluoros is not so dramatic as you would necessarily rip them out. Economics. It's probably more economical to wait till they fail. Step 2, draft proofing. In my opinion, draft proofing is a bit of the ugly duckling in terms of measures because it's undramatic, it's a bit boring. but it's surprisingly important and surprisingly overlooked. It involves the basics of gap sealing around doors and windows, proper treatment of exhaust fans, and proper treatment of vents, flues and chimneys. So sometimes this might need a professional or someone to come into your home and really give you a second opinion. Other times it might just be buying good stuff from the hardware store and doing the obvious things. Ventilated downlights, singled out for particular discussion. Often downlights allow air to pass through them to ventilate the hot bulb, and that's doubly problematic because you're allowing hot air to escape into the roof cavity, which is not a good thing in winter. Step 3, insulation. Again, a broad subject, but I'd like to suggest that the common guidelines that buildings are renovated and constructed to are actually minimum. They're minimum guidelines. They're not meant to be seen as necessarily best practice. For example, the common energy efficiency rating system for 6-star homes, which is broadly applied through the country, is not an exemplar of fantastic efficiency. It is a minimum standard. Don't see 6-star homes as some great benchmark of efficient homes. They are not. In most jurisdictions, a 6-star home is the worst performing house you can legally build. So, in other words, don't be afraid to go beyond the minimum standards when it comes to insulation. My personal thinking is, as a guideline, perhaps consider exceeding the minimum standards in terms of R values by about 1.5 to 2 times. So in a ceiling where the current guidelines suggest an added R value of about 3.5, you might be considering R6 at least. In floors and ceilings, notwithstanding that they can often be very difficult to access and treat properly, you try for adding about R2.5 at least.
That's walls, not ceilings, isn't it?
Sorry, floors and ceilings. Floors and walls. Thanks. Robin. Floors and walls. So, that's it for insulation. Windows. Windows, in terms of their thermal performance, are really the weak link. A single glazed window pane has next to no insulation, conductive insulation capability. And so an important thing to bear in mind is that, in a good performing house, they shouldn't be too big. And consider double glazing. So double glazing, if you're looking at ripping out existing windows and replacing with new double glazing units, that can be very expensive. It may be necessary in some situations. A cheaper, practical alternative is secondary glazing, which I've got some experience with and have been very happy with, and it's much cheaper than new double glazing. Curtains and blinds are an important part of the equation in the thermal performance of windows. Don't forget that. As is external shade. All these are topics in their own right, but I just wanted to give a flavour of our advice across all these different areas. Step 5, appliances and cooking. You might have redundant devices. Don't forget to turn things off. Consider energy efficiency when buying. So most appliances, most important appliance types out there have a star rating that applies to them. When you buy them, be mindful of that star rating, and have it inform your decision. Don't always. You might not always buy absolutely the best performing device, but hopefully it informs your decision. Avoid the worst performing ones. A particular subset of this appliances and cookings is cooktops, because it's one area where often people prefer gas cooktops, and BZE's advice is induction cooktops make a good practical alternative to gas cooktops. I have one, had it for about 5 or 6 years, and I'm very happy with it. Heating and cooling. Our approach, our research, our advice when it comes to heating and cooling: avoid ducted systems, number one. We tend to recommend the use of heat pump systems. In other words, reverse cycle split systems we think are not only good for air conditioning, they also can make very good heating systems, especially in conjunction with other improvements to your home. Often people may have a reluctance or a set of experiences or dare I say prejudice about the suitability of split systems for heating, but I challenge you to have a look at modern, efficient split systems and try them out. They really do work very well. Certainly my experience. And that's all part of getting rid of gas heating, and this important part of not having fossil fuels in your home. Hot water. Solar hot water systems are generally good. They reduce the overall energy consumption of a hot water system by at least 60%, often 75 to 95% even. But in climates like Melbourne's, they can have a high wintertime boost requirement. In other words, over the course of a year, they may reduce your energy by a large amount, but in winter, the energy they need can be considerable. We tend to recommend heat pump hot water services, which look like that. Well, that's one type, looks like that. And they tend to suit, well, the energy needed for a system like that through the course of a year tends to be much less variable. So overall they use similar or even less energy than a solar hot water system, and that energy is much less variable through the course of the year. So in a climate like Melbourne, we tend to recommend a good heat pump system. In a hot climate, a close-coupled, simple solar system like that is probably going to be cheaper and easier. There is a bit of a myth that heat pump hot water systems aren't any good in winter. That may have been the case once, but we don't think it's the case anymore for the good systems. There are still bad systems on the market, but shop around, have a look at the ATA's efficient hot water guide if you want more information, and as well as, of course, the Buildings Plan, which describes it in more detail. Monitoring and control. It's important that householders have a good, clear understanding of their current energy use, and a lot of that's going to have to come about by actually doing some measurements of your own usage. So get a PowerMate device or something equivalent and measure appliances, understand how much energy is actually still being used when you think everything is turned off. You might be surprised just how much energy is still being consumed when you think everything's turned off, because there are probably other things lurking in the corners of your house that you'd forgotten about. Set about to minimise your standby power usage, and make good use of your smart meter. All of you probably live in a home in Victoria that has a smart meter by now. Does anyone live in a home that doesn't have a smart meter yet? Someone from Geelong. Why don't you have a smart meter, Bruce?
Interval meter.
It's an interval meter. Okay.
Yeah, it's not smart.
Okay. The smart meter rollout was supposed to have completed by now, but obviously it hasn't gone everywhere up to back.
Would you like some comments during your comments?
No, for the most part, we'll wait till the end. Thanks.
If our smart meters are a big problem, is that something?
Let's come back to that. Hold that thought. When I say make good use of your smart meter, I don't mean just going out and having a look at it all the time. I mean, get an in-home display. These are wireless devices that talk wirelessly to your smart meter and can give you a real-time display of the power usage from the comfort of your kitchen, if you like. Stick it on your fridge or on your kitchen bench. That's one sort there in my kitchen. They come in different types, but they're useful in getting an appreciation of how much power your home's using from time to time. Your electricity distributor or even your electricity retailer might have a smart meter portal. In other words, that's a web-based capability that you can log into and look at historical data up till usually yesterday, the day before, the day that you're looking at it. And that's again a good way of getting an appreciation of your own personal patterns of electricity usage. So encourage people to become more aware of how they use their power. Okay, last step, step 9, solar PV. First point, solar is a good investment. Overall, even with feed-in tariffs coming down, it still makes good sense in the context of reducing your energy spend and achieving net zero energy. Of course, the actual financial performance of the solar varies a lot with how much an individual household can increase their self-consumption. In other words, how much of your own solar power you can consume within your own house. And that varies a lot with what sorts of devices you have in your house, how often you're there, and your own habits. But more about that on another time, perhaps. As a rule of thumb, 4.5 to 5 kilowatts for a typical home is probably a good amount to aim for. And family home with the measures that we describe in terms of energy efficiency taken, you might reasonably expect that 5 kilowatts of solar PV over the course of the year will generate as much or more energy as the whole house consumes. So in other words, 5 kilowatts is hopefully going to be enough to achieve that net zero. And there's a lot of advice that I could give about buying PV, but if I could just put it in one word, I'd say go for quality. Expect that buying PV is something that you want to have last at least 25 years. And there's been stuff in the paper in the last few days about low quality PV installations. But on the other hand, there are some good reports of PV installations that are over 30 years old. That, I can point people to PV panels from the late 70s and early 80s, which are still in use today. So, in other words, don't skimp on the quality. It's going to last you a long time if you do it right. So, they're the 9 steps. The theory, as we described it in the buildings plan, is sort of summarised in that chart, which I think nicely shows this idea of having an energy baseline in a home and having multiple steps successively applied, successively reducing the overall energy required down to a point where you've got much lower energy use in terms of megajoules per day, and then that remaining amount of consumption is offset by the solar on the roof, leading to a net consumption which is possibly slightly negative. In other words, in this hypothetical example, based on the modelling we did for the buildings plan, the house is generating slightly more over the course of a year than it consumes. So that's the theory. And it's important to indicate that this is not just a theoretical exercise. this is an example of it in practice. This happens to be my own house. The last year before I started making significant improvements was 2006. Each column is a month of energy. The red is the gas and the blue is the electricity. You can see that through the course of 2007 to 2011, I've reduced the electricity and gas. And then in late 2011, the gas is disconnected. The electricity in 2012 has gone up as a result, but still overall the energy's continued downwards. So this is real. This is not theory. It's actually happened. The overall result for me personally was a reduction in gross energy consumption of the household by about 75%, and that's with the same occupancy through that time. Actually, the occupancy went up slightly, so it is slightly conservative. If the occupancy had stayed the same, it's likely that the energy consumption would have actually looked slightly better than this, but I'm being conservative. And the net result for the end of 2013 was what I call a supply balance of minus 2.8 kilowatt hours per day, which is this number, 18 kilowatt hours a day of generation for the year, minus the 15.2 kilowatt hours a day consumption for the house, gives a net balance of 2.8 kilowatt hours per day in surplus. Electric cars using 3.2. So overall, I'm consuming from the grid, but with excluding the electric car from the equation, I'm better than net zero. So that's a real picture of a house that has done it. I hope I won't be the last. I know from the course of this process of talking to people and talking about energy freedom and the Buildings Plan, there are others already out there doing this. You know, Peter's in the audience, he's doing it. Adele, who's not here, another BZD person is doing it. There's people out there starting to put this into practice, which is very satisfying. So remember, energy freedom is net zero without fossil fuels. Look out for the book. We've taken the learnings of the BZD Buildings Plan as they apply to homes. We're calling it, the actual title, the working title at the moment is Your Energy Freedom Home. We'll see how it comes out when the publisher actually produces the book. It's with the publisher at the moment. We hope it will be available in September. James, do you think we should take questions now, or do you want to hold them to the end?
Well, let's do both. Yeah, I think if I could manage the questions to Richard in a way that will help my section too. So let's maybe some applause for Richard. So yeah, I'm James. I guess I've worked and volunteered at BZD for over 6 years now. And I helped produce the Buildings Plan, sort of executive summary and that type of thing. And while we were putting it together, this executive summary, we realised there's a story there. It's not just research that, can happen. It actually has a real story for Australian households that if they did all these changes that we were recommending, they'd achieve something quite transformative, and it needed a name, and we tossed around quite a few names and landed on energy freedom. And out of that, sort of the interest that the Buildings Plan generated, we started a new initiative, and that initiative is called the Energy Freedom Initiative. And the goal of this initiative is to share this information that Richard's just created in a way that Australian households can act on. And so we've got, if we could just hand these out, that should be enough for the row. That way. hang on to these. If you're not yet on the Energy Freedom mailing list, you can sign up on the back and just hand them in to Miwa on your way out. But hang on to them for now because I want to use them. So I have to hang on to them. Sorry. Who's going to stay on? You rely on that. All right. So to help this initiative, which is quite new, I wanted to really pick the brains of this audience, which I know is a very engaged audience. You guys have been coming to discussion groups maybe since 2007. I think that's probably when they started. Or maybe this is your first one. But you know about BZE or Melbourne Uni. You're definitely at this, you're in knowledge compared to the average Australian. And Richard and I were out in St Albans talking about this, and some of it's quite new to a lot of people. Let's just say that. So what I wanted to do was find out how many of these steps people have taken already, and then we can start to, for want of a better phrase, pick Richard's brain, and also lots of people in the audience have investigated at least doing one of these steps or have found something out while trying to do it or achieved one of these 9 steps. And out of that, it'll really help us build this initiative. So when we're out on stalls in Melbourne and different places talking to the public, we can get a sense of the types of questions and challenges that people are facing once they're inspired to do this. So what I think we'll do is actually use Richard's presentation. I've spent many years writing presentations and I've had enough, so we'll just use Richard's presentation. So if we could just go to the first of the 9 steps and put up the notes, and that'll give us a bit of a frame. Yep, so let's start with lighting. And if we could just have a show of hands, how many people have changed their light globes to LEDs in their house? Some, yeah. Or maybe we'll do how many people do not have a single halogen in their house anymore. Alright, so that's maybe about 70-80%. And did anyone have any lessons or I think unique takes while doing the LED swap out, or was it pretty simple? Yeah, we'll see it. Yep.
The challenge I had with LEDs was, I didn't like them because they had a heat chimney effect, so I just replaced it with what was initially just going to be a series of oyster lights.
Right.
But I found that the LED outputs for those sorts of lights just didn't cut it.
Right.
So I went to compact fluoro lights.
That did the job.
Yeah.
Right. Any other LEDs? We'll go here. And the gentleman in the purple shirt. Yep.
On low voltage ones, I've had problems with transformers.
Transformers, yeah.
Power demand has been too low.
So I might grab a few answers and then we'll throw to Richard, and if you can keep track of the commentary.
And the other one is interference on radios.
Radios. So we've got radios, not enough light, and low voltage. Gentleman in the purple shirt.
Dimmers on the LEDs upset them a lot. But the biggest frustration is I've got a sensor light that I just put a compact fluoro in, and they just don't like it going on and off all the time.
Right.
Kills the compact.
Alright, we might grab 2 more. Yep, there and then right at the back. Yep, sorry.
Two things. One is the colour of the LEDs is, I find awkward for reading sometimes.
Yep.
And the other is just a question about I'm sure this is an appropriate point for it. The building report suggested that LEDs would be at around 150 lumens per watt, and the best I can find is still around 60 to 80 lumens per watt.
Okay. So light output.
Question on notice.
Yeah, for sure, Richard. And gentleman right at the back.
Yeah, just to add on that one, it's hard to find credible information out there about the quality of the product or performance. And I found that when you choose the product, most of the time, 90 out of 100, it is likely to fail the expectations that you make in company.
You're right.
The products you buy, random brands, not talking about all brands of this.
Yeah.
A lot of people in the market.
Sure. Okay, we might throw to Richard, although he seems to be exiting stage right.
I'm just going
Good bag of goodies.
to
Okay.
down the points as they
Oh
arise.
yeah.
There's some.
Is another VZE person able to take the notes and then thanks, Sinead's on. Okay. So Richard, you're free to
Okay, good.
pick your own brain now.
Point about the colour quality, they're improving a lot. Look for a property called the Colour Rendering Index as a measure of their colour performance, and also the colour temperature is a factor in terms of the perception of light quality. So bottom line is, like with any product, there's a variety of quality out there. Go for the better ones. The point about lumens per watt, in the buildings plan, that was in the context of a 10-year proposed rollout. And we chose 150 lumens per watt as a reasonable estimate of what lighting performance would be in about 3 to 5 years. Not meant to suggest that that's what it is now. It's up to around that level in the labs already. We expect that by the end of the decade it'll be in the order of 200. But these, at the moment, good quality ones are in the order of 80 to 100. So hopefully that puts what we've put in the buildings plan in context, that it wasn't meant to describe what's available today.
Sorry, I think we had Grunt, as in he tried LEDs and there wasn't enough lights. In Oyster, what kind of?
I just replaced the halogens with a single oyster,
Yeah.
Right.
and I certainly didn't get enough, effectively what you're saying, enough
Yeah.
lumens per watt,
Yeah, right.
Yeah.
despite the blurb on the packaging,
Yeah.
Yeah.
So
which is exactly what you were saying.
Yeah. Okay. And your
I had several fittings that were the same problem, and I had to buy from eBay the fittings where all the LEDs face downwards. Basically, like, look what was going, and obviously like all of the LEDs faced in one direction.
yeah, right. So light
Australia,
proof.
as far as I can see. But they then work perfectly.
okay, interesting. And there's a point about the transformers.
Yeah.
Yeah, often it's good to buy a matched set of the transformer with the LED, and that's one of the partners of Energy Freedom, Cherry, actually sell them as a matched set, because it can be a problem both because of the low power consumption doesn't work with that transformer, and because of the potential to induce radio frequency noise. So look out.
Did we? I think we're getting more questions, but the gentleman in the purple shirt, the question was.
I have got a question. What's the
Oh
difference?
no, this is another gentleman with the purple shirt. Yeah.
So one was the compact fluoros don't work well on sensor lights. It tends to cook them after 6 to 12 months. And the other thing was if you've got dimmers and you put your LEDs in, they,
Some are dimmable.
yeah,
So quality matters.
just to try to look out for.
Okay, we might have a couple more on LEDs, and then knowing we've got 8 more steps, we'll go on. Yep.
What's the difference between Cree and the colour warmth of the LEDs? What figure would you be looking at when you're purchasing the
Colour rendering index, CRI,
compared
is
to the colour, like warm light, cool light,
Yeah.
daylight?
Sunshine is 100%.
the colour temperature relates to how pure, whether it's pure white or slightly on the blue end. Up the blue end is high colour temperatures, warm is low colour temperatures.
Yep.
Whereas colour rendering index is more how the LED can accurately reproduce the colours of an object when it's shone on that object.
Is there a number that corresponds roughly to what people who like their halogens are going to get?
In terms of colour temperature,
Well, either the colour temperature or the CRI.
often
4,700.
4,700 is sort of a mid-range, mid to high. general purpose. And colour rendering index, I've seen numbers of 95 or better.
Is that percentage, is it?
It's related
My-
to sunshine.
Yeah, my understanding is that 100 renders colours the same way as natural light.
Gotcha.
We might go to the next step knowing that if there's time at the end, know that there's so many questions on LEDs, that's kind of good. So we'll go to draft proofing, and again, just for, I guess, our knowledge, sharing this alliance, how many people have stuffed every gap in their house? They're pretty sure nothing's getting out. So you're about 30%, and how many people have at least done something? I'm guessing everyone, yeah. Even I've done something. Okay, so questions on how to get from doing something to getting the whole way, or lessons along that path. And I think I hit too many questions at once for Richard, so we'll just do one at a time. It's going to work better.
Okay.
So,
Yeah.
yeah, gentleman over there.
I'd like to make a point regarding gaps.
Gaps.
With us, those we have a motor and organ dementia. You can have the best house, all sealed, but
Yeah.
open the window or the door when it's hot or when it's cool. With a heating pressure.
Behaviour change. Yeah.
The plan has got to be adjusted to make sure everything.
Check the family and study.
Yeah. Okay, that's a good point. It's got to be
You
educated.
can have the best system, but unless you do your thing properly, in other words, open up at night, get some air, cool air in, and close in the morning as soon as you put the heat and stuff. And the same thing applies to the shell with windows. You've got shutters outside or blinds or whatever,
Yeah.
you do the same thing.
Yeah.
Because there's a lot of heat coming through.
We've made 1920s period home so ventilation tight that we triggered additional condensation problems.
Oh, yeah.
So you just need to be aware of that and how to deal with it.
Yeah. In fact, your house was open for a Sustainable House Day, wasn't it? I think I've been to your place. The question of condensation issues on well-sealed homes often arises. But all I'd say there is that it's whether or not your house is well sealed, you still have to be actively engaged in the ventilation of your own home. Bad draft proofing lets you off the hook a bit, but it's still important, regardless of how well sealed it is, to be opening windows and letting the fresh air in when it's appropriate and closing them when it's hot or cold outside. So active involvement in the ventilation of your own home is really important regardless. Up the back.
Do you think that's almost another category in your 9 points where you have such a rigid system and everything's closed up in the absence of mechanical ventilation systems to control that? You know, I guess something about driving your house, so to speak. For example, gets cooler than
I think it falls well within the category of draft proofing because it's all it's all related to ventilation and the control that you have over it. When you draft proof the house, you have the potential to properly control the ventilation of your home. Mm-hmm. Without draft proofing, you don't have that control. So yeah, but I agree that it's important to if necessary, look at other measures. Yeah.
And two, John and another gentleman in the red.
One thing I discovered when we got rid of gas, we had previously got gas-fired ducted heating. That meant that I had 13 rectangular holes in my fitted carpet around the house. And what I've done is I've simply left the duct covers there, but I lifted them off. I've siliconed, what do you call it, not MDF, but hardboard rectangles into the bottom. I stuck a piece of carpet over that and then put the vent covers back. So the house still looks like it's got vented heating. It's cheaper than replacing the carpet all around the house.
Yeah.
The other thing, and the other big saving we did. We've got a 1948 brick veneer, and in the east wall there's a low window, and of course the low windows they fitted back in 1948 were fixed open louvers. And going to the loo at the middle of the night on a cold winter's night was not a pleasant experience. So I ripped out the louvers. I put in a single glazed window, but as for a window that size, it's not worth getting a double glazed unit. And put an extractor fan in the ceiling and a timer switch by the door. So you go to the low, you finish your business, and you push the timer switch as you go out, and the fan runs for 3 minutes and gets rid of it and changes the air. So it's great. And it's much nicer at night.
Good idea.
I'll sleep better knowing that.
This is a bit of information from a specific situation in the ski club, and that is that by putting a dehydrator into your drying room, where you take out the moisture that's being generated, one, it saves having to have a ventilator going out because the air gets saturated. But that also saves your heating bill because you've got dry air, and we, for a cost of about $500 in a ski club, we've taken probably about nearly $1,000 off annual energy bill by doing that.
Well done.
All right, we might go to number 3. I think I'm timing it pretty well. And that is insulation. So we'll start everyone has some insulation. All right. In the roof? Yep. Under the floor? A little bit less. In the walls? Yep. That's all there is, isn't it? Okay, just checking. There's only 3 bits. And
the garage door.
Garage door. Okay, now we're getting tricky.
24 degrees.
All right. So questions about insulation, and from our experience, a lot of it is about how to get it in the walls. So just to reiterate, we're about retrofitting, if possible. So bog standard brick veneer home from the 1960s, we're saying can generate more energy than it uses in a year and achieve net zero. So we're about retrofitting. So questions around insulation and retrofitting to your existing place. Yep.
I guess I just want to talk about my experience. When we had wall insulation done, they said there's about 4 different variants, depending whether you've got tiles or tin. Obviously tiles is much easier, they take the last row of tiles off. Weatherboard's easier, they do holes. We had the worst combo, which is tin roof and brick veneer.
Yeah.
They had to take 40 individual bricks out by grinding out the mortar and brick. They could do it. It was quite a nightmare. There was mess everywhere, and now they look pretty awful.
All right, so 40
they
bricks.
They had heritage brick layers that matched it perfectly.
Yeah. Oh, so they smashed the brick.
It's good in terms of insulation, but probably weren't that happy with
the actual brick.
But if you had the other solutions, it can be done in a day, especially with the tiles.
Yeah, I had pumped insulation through both weatherboards and cavity brick. And in the cavity brick, they were able to inject it into the mortar, or through the mortar. They drill holes in the mortar, and so the bricks didn't need to come out. So the systems vary.
How readily available is that system?
There aren't many people who do it. I think the demand isn't sufficient yet, and so I'm only aware of one company that's doing it.
It's just like foam, isn't it? It expands.
It's a 2-part water-based foam that goes in like shaving cream and sets like pavlova.
We have done with basically waffle, granulated waffle.
Oh yeah.
Right.
Yeah.
Well, it said that sort of a system often pops the plaster off. You didn't have any problem with that?
Yeah, some expanding foams actually expand inside the cavity. The one I used didn't. It expanded in the nozzle and went in like expanded shaving cream. So there was no additional expansion within the cavity. The main issues around it were that as it cures, it emits water vapour. So if you don't want to do it in winter, because the water vapour is going to come inside and leave it moist. And if it's done behind weatherboards that are painted with an old lead paint, then that will lead to some bubbling. So modern oil paints and acrylic paints are water vapour permeable, but old lead paint is not. So that was the only consideration from my experience.
How does the moisture go with PowerPoint, Richard? Yeah.
You need to have those external walls all dealt with before the insulation is put in, and what's called a shroud goes in behind every PowerPoint or similar fitting, so that the PowerPoints aren't fouled. Yeah, so and an electrician needs to come and make sure that the rating of the wiring isn't exceeded, because the thermal rating for electrical cabling is different if the wiring is fully enclosed versus whether it's in air. So yeah, there are some considerations that are sort of second order considerations when doing wall insulation.
Can you comment on whether wall insulation would be reversed in a future climate where you get a prolonged heat wave but you're not getting the increases to purge the panels?
Still definitely even more worthwhile, I'd say, because in future warm climates you've got that extra thermal stress that you want to minimise, and the heating or cooling system will be able to better cope with maintaining a comfortable indoor temperature if the insulation envelope is intact and robust.
Just a couple more. Yep. My build was a new house, right? And thermal mass, I tried to make use of thermal mass under the house. As I said before, I've got an insulated door, well-insulated door, which normally keeps the temperature inside under the house 24 degrees. But also behind the garage, I've got two 15,000 litre water tanks. And the thermal mass of that keeps it at about 20 degrees. Right? And during the day, if it's heating up at the top, the fan just sucks some of the air from underneath.
Yes.
So that's, I mean, it's extra cost, but if you're doing this as a new house, just think about it.
Yeah, thermal mass I've excluded from this list only because our discussion applies mostly to retrofits, and thermal mass is really hard to retrofit. And my personal opinion is that insulation is much more important than thermal mass. I think perhaps we need to move on.
Okay, sorry, we can come back. Okay, windows. So I don't even know how to do this. Who's double glazed all the windows they want to double glaze? Some, yeah? That's a good way to ask. And so about 40% of us have double glazed all the windows we want. Yep. Questions about, and again, retrofitting double glazing around that. Questions or comments? Stumped it, really. Yes.
I have no relationship with Alan, but I take exception to you saying that the double glazing is very expensive, because I reckon double glazing, you can do it yourself double glazed, is actually quite economic.
Okay.
And often cheaper than doing secondary glazing. So I think you need to, if you go to an outside major contractor to do it, yes, expensive.
Yeah.
But if you're doing it yourself, it's quite different.
Yeah. No, I think that's fair. So, and for the benefit of people who aren't aware of what Robin said, I've, for the purpose of keeping the message simple before, I've lumped glazing improvements into either do secondary glazing or rip out the windows and put in new double glazed units. But in reality, there's a middle ground, which is to remove the single glazed elements and replace them with sealed double glazed units, and work within the context of your existing window frames. And actually, Alan Cuthbertson, who's here, runs a business that does that and does it very well. So, in terms of the performance and cost, that approach is perfectly sound, and you make a valid point, Robin.
Another one is just thermally improved single glazing section, certainly not built up. It's like a plus or some product like that. So and it improves thermal performance, but you can retrofit standard windows.
I'm not aware of any products that make substantial improvements to a single glazing window.
He's talking about a low E solution,
Yeah,
which they claim is as good as double glazing, but I question that.
yeah.
Or even a laminated glass improves the
Just a thicker piece of glass can improve it.
Not as much.
But not by a lot, not by a lot. Because the actual U value of a single glazed window, the actual thermal conduction, the so-called K value of the glass, is a very small contributor to that. Most of the net effective insulation effect of a single glazed window is from the air glass interface. So you've got two air glass interfaces in a single glazed arrangement, and that doesn't change if it's slightly thicker glass. So thick glass doesn't really change the U value very much.
Just change the sound value.
Yeah, well, it improves the acoustics a lot, but not the conductivity. So you really need that air gap in there of at least 5mm.
Yeah, just wanted to give an indication. I changed all my windows to double glazed, removed the old ones. It's a 24 square house, only about 12 large floor to ceiling windows. It cost me just over $20,000.
Yeah.
Big difference in winter.
Yeah.
Really huge.
Yeah. Yeah. My house, by way of comparison, is a 200 square metre period home with a bunch of period windows that I didn't want to throw away. And I used a product called EcoGlaze, which is a secondary glazing solution. Overall, about 50 glazing elements. So like one large window might have 4 or 8 different pieces of glass in it. So, and that costs about $10,000 or $11,000 to do the whole house. So a lot cheaper than ripping out windows and putting in new double glazing.
And I did my own secondary glazing, which is about 40 or 45 elements, which is about $3,000.
Yep.
Basically doing the same idea as EcoGlaze.
Yep.
I'll have one more and then we'll go.
I went to a rental property once and they hung cafe blinds around the inside of the house, and they said that was really amazingly effective. Cut their the winter heating costs enormously.
So cafe blinds are those sort of clear, thick plastic.
Like you buy them from Kmart, they're about $80-90, and they just had them hanging inside the house on the original curtain rods.
How aesthetically attractive.
Oh, beautiful.
Last one.
If you really want a cheap solution, the bubble wrap on windows is really good and really cheap.
Yeah.
And for bathrooms and laundries where you don't want to see them anyway,
yeah, that's true.
Bubble wrap is fantastic.
Yeah. That's good. I did that at my last rental.
I can comment on that. I have a skylight in my hallway, and I've improved the thermal performance of that with something like 15 or 18 layers of bubble wrap just sitting on top of the skylight element, which is removable. So, yeah, I concur.
All right, let's go. Huh?
Let's go back to the last slide.
Okay.
The external shading. Has anyone used a wall garden? And what's the result?
I think it's a good idea. I'd like to do it at my place.
So anyone done?
So the question is wall garden. So
rather than planting the tree there, which will take you 10 years or something, to affect the shade, what do you do in the meantime?
Yeah, it's a good idea.
We have the serious trees.
But they take
That's
time.
what I'm trying to do.
Yeah.
You know, I'll always want trees there, but eventually they will cover north facing and west facing walls. So in winter the sun does come through because there's no leaves.
Yeah. But in the meantime, wall gardens. Yeah. And I saw a property that had roof garden around its solar, because solar performs best at 25 degrees, and so in the middle of summer you can have some green, absorbing some light and heat. Then he was saying his solar is more effective because it's brought the temperature down. So anything green we're obviously for. So plant away. All right. It's just a top of the head.
Appliances and cooking.
Yeah.
Does anyone here already have induction cooktops?
I think I have one.
Good.
Has anyone, actually, this is a good question. Who here has had gas and disconnected it. Okay, cool. On the sign-up forms, if you haven't already, one of the big things with energy freedom is sharing success stories. So Richard's probably the original success story for energy freedom, but we want to share more and more of these with people because it gives different perspectives, and people in the public might say, oh, I've got that kind of wall, or that, I've got that type of house and this person's done it and this is how much it cost them. And so if you've got that, if you fill out this form and just put success story, then I'll know to contact you if you're happy to do it and share your story. Or if you're planning to get rid of gas or you've done some things, just let us know and we can share your story.
Does anyone have any concerns or reservations about induction and its relative performance compared to gas?
Well, not about relative performance, but this is probably rubbish, I don't know, but you do read that pregnant women shouldn't stand too close to them and this sort of thing.
I'd be more worried about a pregnant woman standing next to a microwave, honest, than I would about them standing next to an induction cooktop.
Isn't the other issue there that you've got the infrared?
Pardon?
You have the infrared rather than induction?
Well, I'm talking about induction.
Right. Because the infrared is, of course, even more efficient than...
well, I'm not sure about that.
I thought it was 54% in the induction of that 40%.
Ronnie?
How do you go about
Wok cooking? A couple of different approaches. Some of the high-end induction cooktops have a concave base, and you can actually put the wok in it. Personally, I just use a deep skillet in lieu of a wok, and it works fine.
Flat base?
Yeah, a flat base, but deep on the sides, and just keep the food moving through it, and it works fine in lieu of a wok.
That's the one and only thing that we've still got as an electric thing. We've got a standalone electric wok.
Oh, okay. Right, yeah. Plug-in one.
Plug it in.
Yeah, that's a good idea. Yeah, comment here.
Got one up the back.
My comment is that a lot of what we're talking about tonight, and I find this often when I'm looking at energy efficiency, doesn't relate to where a lot of us live, which is in flats or apartments.
Yeah.
And even just this issue as an example, our flats were built in the 60s. They have got provision for gas heating and gas cooking. People have been moving across to electric cooking and also putting in air conditioners. And another electrician alerted us to the fact that we are probably about to reach the capacity of the electricity coming in from the street. And when we had it checked, this is in fact the case. So we're asking people not to put in more electrical appliances at the moment. We tried to get it costing on what it would cost to upgrade the electrical capacity. Figures like $100,000 were talked about, and this is just 33 flats, so it's not something you consider. And even if we were to apply to do that, City Power mightn't have the power will enable us to. So I just want to draw your attention, that was just an example, but lots of what we're doing, even the smart meters, we can't see our smart meters, they're several steps. That's right. You can go and unlock and get into them. They're just not accessible in the way that you're talking about.
Well, so two issues there. I concur with the point about the capacity of the supply into a multi-residential building. That certainly has to be taken into account. In terms of the access to a smart meter, the point about smart meters as deployed in Victoria is that they have a wireless interface, and when it's set up, you don't need to access the physical device. The in-home display talks to the smart meter wirelessly, so you don't need physical access. So there might be issues about it being on a different floor and not having wireless range to it, but they're problems that can be solved.
It's a long way away from most of us.
Yeah, there are products that serve as gateways that bridge that gap, but
Does the partner in Energy Freedom Alliance work with that?
Totem, they connect wirelessly to the smart meter, and do they boost this? Are you allowed to boost the ZigBee wireless signal.
There are products that do that, but I'm not sure if our partner does sell those.
Stepline has a device which looks at the LED flash from the smart meter, which corresponds to a defined amount of energy used.
Yeah.
And that can then wirelessly.
So if you can boost that wireless signal.
Yeah, the only trouble with that is if you've got solar, it's hard for it to distinguish between import and export.
Yeah, I don't think that's the case with the flat stuff.
Yeah. We might, because we've got 3 more and we've got probably 10 minutes and then might have closing. So this is a massive one, is heating and cooling. I mean, it's a huge part of people's energy bill, especially in Victoria. So how many people are using reverse cycle heat pumps, air conditioners as their form of heating? I can join you guys on that one. Okay, and how many people have gas ducted heating at present? I know you're about to change, Peter. So, and of those people who have gas ducted, are you interested trying to get to reverse cycle air conditioners, or are you not sure?
Interested.
Interested? Not sure? Any not sures?
No, reverse cycles to go because you could use them in summer as well.
Okay. Anyone not in that feeling?
Just to add to that, we've also got ceiling fans.
Of course, yeah. Reversible, yeah.
You don't need anything else.
Okay.
Once you got reverse cycle on those.
Oh yeah, reverse cycle plus those.
Plus the ceiling fans, they make everything.
Our house is 150 years old. It's fully heritage listed.
Yeah.
We're bluestone, and to get anything other than gas ducted heating would cost us $40,000 to remove and then replace. So for us, it's just not possible to get off gas heating. Maybe for gas induction and that sort of stuff. So instead we've decided to double glaze all the windows, seal up all the gaps, put up really thick curtains and blinds and hope for the best.
Are you saying not allowed to have an air conditioner?
No, we can have an air conditioner, but to completely retrofit and get the gas system out of the house because it's built into the walls, it would cost us over $40,000 to retrofit. Yeah, so
disconnect the gas.
Yeah,
All right.
it's freezing cold in winter. So we have 14 foot high ceilings, and it's impossible.
When you say it's going to cost us, I think we should go hydronic system.
I don't know what it's called.
Maybe people can come and chat to Sinead afterwards.
No, it's not water, it's all gas.
All right, so let's talk about getting off. Yeah, the transition from.
We'll take it as a challenge.
Yeah.
Very good.
Okay.
When you get the gas disconnected, we had the experience of sitting in bed one morning and there's this bloke wandering around the front garden. We investigated and found it was the gas meter reader looking for the meter. It had been taken out and hadn't told on.
That's good. All right, gentlemen, agree?
I've got a small house, probably about 120 square metres, and I'm down to about, with electricity down to about 3 kilowatt hours per day.
Yeah.
But I've got ducted heating.
Yeah.
So I'm just wondering what my kilowatt hours per day would be if I went to the reverse cycle.
Yeah.
Like others, I don't have a need for summertime use because I've used fans and I'm pretty much happy with that.
Yeah.
So I'm just wondering what that would lift myself in the winter time. That's probably the only thing I can really relate to.
I wouldn't hazard a guess because I'd need to know more about the details of your situation. But what we could confidently say is that if you take your current energy, that is electricity plus gas, that's megajoules a day, and you get rid of your current heating arrangements and move to a split system, what you end up with will be substantially less in terms of overall energy use. So your electricity use will go up, but the overall energy use will come down.
Okay.
And Tim Forsey here, who did some calculations, it was about 40 cents to the dollar in savings. So save 60 cents, 60% compared gas ducted to an electric heat pump heating. So it was in 2013 prices, assuming that your gas ducted system is all connected and not leaky and the dog hasn't torn out one of the pipes and that type of thing. So
you just replace the burner, do you, and put the
No, this is in wall versus gas duct. So in the room.
Utilise all the ducts and have a...
No, we don't really think ducted is that efficient because you're running your air through your roof or your floor. Yeah.
So what I've done is remove the ducts from my ceiling and blocked off the vents. Luckily, my ceiling registers, the vent elements, had foldable flap in behind it, so I was able to fold those down and then silicone them up.
Yep.
So they still look intact and present, but they're actually completely blocked off.
So how do you warm the whole house up if you've got a split system? You can only warm up certain rooms or areas, can't you?
Yeah, well...
So you need 5 air conditioners in the house to compensate that.
Well,
You need to warm the house.
you have as many indoor split system elements as you have places that you want to heat. But it overall tends to work out better than a ducted arrangement for lots of reasons that are in the book. I'm happy to talk to you about that.
Lady in white. Okay.
I've got both a ducted gas system and a gas space heater, and I discussed changing to reverse cycle with my plumber when I was having some repairs done. And he was dead against reverse cycle split systems. So you're doing anything to educate the tradespeople?
Sounds like we need to do more, but yeah, absolutely. I think someone once said people like to do tomorrow what they did yesterday. So if someone's had 30 years experience installing a certain system, tomorrow they're probably going to want to keep doing that process. And so yeah, there is a big need to have the discussion. I think you don't want to come in with we know all attitude, but yeah, I mean the science is kind of in on electric powered reverse cycle heat pumps being much more efficient and cheaper to run than gas. Like there's just...
Well, he was saying they wouldn't get hot enough.
Because he would lose the trade.
Yeah, plumbers, yeah.
On that same topic, the air conditioning people have no concept of efficient houses as well. They didn't think double glazing or anything else made a difference. They wanted us to have an 8 kilowatt.
Yeah, they want to oversize. So it's not like the air conditioning people are the goodies because they just want to sell you an oversized system. Well, not they, but many people will quote you a 5 kilowatt system per room when if you retrofit and insulate and seal things, you don't need 5 kilowatts per room. And yeah, so...
Well, he just couldn't grasp that making the house more efficient works and making a difference how much air conditioning there. Insulation, double glazing, all those drafts and said, so he's doing that.
Yeah, I concur. My own personal experience was that I put the reverse cycle system in at the end of the process after the insulation was improved. And like you, my air conditioning contractor said, you need this much. And I said, no, I don't. I'll have this much. And he goes, well, be it on your head. So he basically said, well, that his professional judgment was that I was overriding his professional judgment, and he wanted me to acknowledge that. And I said, fine. It's on my head.
Still got your head.
And I still had my head.
It hasn't been cut off yet.
Seems to be there.
Yeah. Did you go for the bigger unit or the smaller unit?
Much smaller than he wanted, because the home with the double glazing and the draft proofing and the extra insulation needed much, much less than he wanted.
My belief is that, because I install air conditioners as well, and a lot of people want to go the next size up, and therefore the bigger unit only has to work half as hard.
That's true, but you pay for the bigger system.
You pay slightly more, but it doesn't have to work as hard.
Yeah.
But does that you actually save?
But
I think it does.
But there's an inverter in my son's bedroom. I see it actually has to keep turning off and back on again, and the temperature doesn't stay stable. Whereas if it was a smaller one, where it would ramp down but stay on. As I see in the other room, the temperature is a flat line. Whereas his does this.
Because it's a big...
No, it's only 2.5 kilowatt, but in a biggish bedroom.
Yes.
But it's still too big for that.
Yeah.
You have to get turning off. So it's the same thing would happen in a living area where the unit was bigger. It's like you have to keep shutting off.
Yeah, so bottom line is matching...
So, it's not always better that it's not working as hard.
You know, the new ones are inverted, so they just...
Yeah, this is an inverter.
Right
This is an inverter. It ramps down, but it's still not, can't ramp down far enough.
Yeah.
All right.
Bottom line is you match the size of the system to the thermal performance of the space. So.
Yeah. Okay. We might go
Just one more.
Okay, cool. We've got 10.
Thermostat?
Pardon?
Has anyone got a program for thermostat? What's it?
I think every reverse cycle air conditioner, I think.
No, these are the next generation.
Oh, right, this sort of smart.
You're talking about setting different temperatures at different times of day.
Yeah, and it learns your habits.
Yeah, a learning thermostat. Yeah.
Anyone have one of these?
Anyone got one?
Yeah,
I've got something. I've installed many.
Are they good?
Yeah.
Yeah.
Mostly
Cool.
commercial.
Commercial.
They do good.
Yeah, they even anticipate it, so
That's right.
before a heat surge does start.
Vivian? Yes?
I'd like to back up the lady's point about plumbers, and I hope you will do a sort of green offensive with plumbers, get them on side so that they're going to do success stories, they'll tell their stories, because I've had the same problem, and I'm like, Richard, in your book, if you could have a little dialogue that we can tell with plumbers, because when they say things, it's very hard to be assertive.
Yeah.
I've been to your talk on heat pumps, and I've tried to persuade them going about heat pumps. He told me it would be so crazy, it was impossible, if you couldn't get it. I phoned up Earthwork and they couldn't do it in Sydney, blah, blah, blah. He ended up getting like a gas system, or again, after my old one rusted after I've been determined for about 15 years to get an electric one, but he just wouldn't have it. He was, he wasn't going to let me suffer so much. And so,
How could he do that, Vivian? Take him down.
I couldn't argue the point he was telling me.
Yeah.
Get a new plumber. What can I say?
Well, we might have to start certifying educated plumbers with your report.
Yeah, but you make a good point that there's a strong resistance against some of these ideas within the trade.
Yeah.
And I take your point that we need to have an engagement with them as a. They're not silly people. They just perhaps not as informed as they should be about how well the new systems work.
BZE endorsed plumber.
Well, we don't endorse. We could.
Go and drop for a small thing.
Yeah. Okay. We'll go on because we've got 3 steps left and not much time to dance. So we'll go hot water. So again, how many people have gas hot water? Actually, that's a silly thing to ask. How many people have pure gas, only gas hot water? I think I have both. How many people have pure electric hot water? Oh, sorry, yeah, I've stuffed that out again. How many people have, it's hard to label. Solar hot water with a gas booster. Yeah, that's the majority of people. And how many people have heat pump hot water? 3. Yeah, cool. We got to you guys.
And I've got solar hot water with an electric booster.
Well, yes, that's right. You got the last one. Okay. All right. So questions. So I guess in Melbourne we're saying that heat pumps are tipping the scales. And Tim, again, there's a great article on The Conversation that appeared last week about how if you've got solar, how having a heat pump hot water system is a great way to maximise your solar. And then, and I guess it goes back to Vivian's problem that most people are deciding on their hot water system when their old one's broken and they're standing there cold, wet and naked, which is not the best negotiation position. And that's definitely Tim's line, or that he borrowed off someone. But the point is, we've got to kind of talk to people before they're in this compromised position of replacing their hot water, because otherwise they'll just go like for like and have their hot shower in the July morning and go to work. Yeah.
Yeah.
Yep, I've got a net zero pump. I've got a flat panel collector, which is, it's got an annual yield of about 4.5 kilowatt hours a day.
Yeah.
I've got a hybrid solar system, so my PV system goes into storage. The hybrid inverters have programmable contactors, and what I'm able to do is, when I would normally export, because I hate exporting, I use that excess energy stored in my hot water tank by heating my hot water using the excess solar instead of exporting. And I did the maths on all the systems, just like you did. My maths didn't quite agree with the no doubt about it, the heat pump system is quite good. And without doubt, they now operate comfortably down to -15. But a system, the best system is a heat pump with the solar.
Yes.
That's
Yeah, I recognise that, but...
Then the next best thing would be where you have this ability to share your exported power. You're effectively getting around about 6 kilowatt hours of storage in one of those units. So if you would normally export 6 kilowatt hours during the day, you can put all of that in.
Yeah, which is exactly the point in Tim's conversation article. There's a complementary arrangement of flexible electrical loads in your house, of which hot water is a great one, and your solar. So there's a synergy that people haven't taken into account between PV and hot water.
And a very effective upgrade for people who have got a dual element hot water service and no other heating system is in New Zealand they're marketing a variable voltage inverter, and you can put a couple of kilowatts of PV on the roof of your house. You connect the variable voltage inverter to the lower element of the system, and you leave the top element connected to night rate boost like it used to be. And what happens is you're using the PV to heat the water. And it's actually in New Zealand, because of the plumbers having the solar systems, the solar water locked up the way that's actually more economical to do that than it is to go ahead and get a conventional system. So just a variable voltage inverter, a couple of solar panels.
There's some interesting trade-offs there that perhaps we can talk on another occasion, but in general terms, it's another way of achieving the same general goal of having an electric hot water done efficiently.
Yeah, I've got bottle gas boosted evacuated glass tubes, if that's not too much of a mouthful. I've got a tank that looks suspiciously like your tank there next to your heat pump, and I'd love to get off bottle gas. How easy is it to get just the heat pump bit, convert my thing into a heat pump boosted evacuated glass tube solar system?
Yeah, it's easy. There's a product out there called the Siddons Bolt-On, but as Peter Costello here is in the test, they're a bit noisy.
Yeah.
So the answer is it depends.
Can I add a second question, because my reverse cycle air conditioner thingies are on the roof of my house, where if they were on the other half of the roof they wouldn't worry me, but they're not too bad. Does that have to be next to the tank, or can it go on the roof as well?
It's a heat exchanger. Most of them have a water circuit here, so it's limited. It can be separate, but not too far, because otherwise you'd have too much losses in this circuit. The more efficient heat pump hot water service that I'm generally recommending these days is the Sanden, which looks much like this.
Sorry, is what?
Sanden, S-A-N-D-E-N. It looks like this. This isn't the Sanden, but it looks very much like it. It has a CO2-based heat pump unit, extremely efficient, and per your point, it's really, really quiet. And I think they can be sold separate to the tank, so you might want to look at a Sanden without getting the tank bundled with it.
Right, we might just touch the last two, I think. So that's monitoring. We kind of touched this one a little bit, I think. And what's the last one? Solar. Okay. I think we'll go to solar because that's the exciting bit, and we feel. And you can come and chat to Richard and myself about.
This is a big area, though.
Yeah. Are there any points or burning questions that people have about monitoring?
Well, we've got to finish at 8, Richard. So that also burns tight. And I want people to make sure they know how to. People can start filling out the form, and we can go straight to 8.
Okay. So
you can save me spiel.
See me afterwards if you've got burning questions about monitoring control.
Yeah.
So solar PV.
How many people have solar here? Like, this is what we're finding out there. Most people at this point have some solar, and it's about maximising the solar to get to net zero. But questions, thoughts about solar and using these other 8 steps to maximise the solar you've got on your roof and investing in.
We have solar hot water and considering putting in the solar PV panels.
Yes.
But we have no control whatsoever with planning, and the house next door belongs to a very old lady, and we could quite easily have a 2-storey place built there. What guarantees do we have?
You don't have any.
cut your solar.
Yeah, your overshadowing is a risk, and I guess you just have to plan around that.
But don't worry about it, just put the solar in and loosen. Put lots of solar in.
But on the other hand, it might be
It's a single front terrace.
it might be 15 years before that overshadowing happens. It might be 15 months. I guess in your case, it's hard to plan around it.
She's 94.
What
And we've just had the next door neighbour totally build out our sky.
Yeah,
This has
right.
really freaked us.
Yeah.
So we've got no sky anymore because we've had a very large building put down the back of their property, so we no longer get sun.
Can I suggest you look at installing it on your son's house or one of your... I mean,
No,
it doesn't matter which house it's on.
No,
If your
I've
son
already
or your
done
daughter
that.
has a good house, put it on
I
there.
put it on our children's house because I was...
Ask if you can put it on their house, the one that took your son. So, come on.
Although no objection
I
to
mean,
your house.
are we looking at planning regulations to give some sort of guarantees for people that are putting in this?
Yeah.
We're going to be built out, we have a balcony that can be built out, they can build right to the boundary.
Yeah.
It's a tricky question.
Property laws going back
Yeah.
800 years. You're entitled to your sub-market bathroom. This
Yeah.
is to do with very old property. But
Yeah.
that's difficult.
My husband is an
Magna Carta
architect.
didn't say you were entitled to something.
My husband's an architect and he looked at the planning and he got his friend who's another heritage architect to have a look and he was told, be grateful for what you've got. So that's planning again.
Yeah. So I think we'll just have to take that on board as a known issue, but it's sort of outside the scope of what we're looking at. I think two more questions.
With your normal PV system with a single inverter, if one panel is shaded, does the performance of your whole system drop down, sort of limited by the one panel that's underperforming?
It can and it depends. Individual panels have what are called bypass diodes. So there is a series, what's called, please excuse the divergence into a bit of technicalities here. There's a series circuit that runs through not just each individual, not through the set of modules, but also all the cells within all the modules. So it's one big long series circuit with hundreds of individual cells. And if any one of those, if not for the bypass diodes, if any one of those were to fail or be shaded, then it would effectively open the switch and you wouldn't generate anything. So,
If you use microinverters.
yeah, that's another issue. But each PV panel has probably 2 or 3 bypass diodes. So rows of cells. If anything in there goes open circuit, it bypasses that group of cells. So yes, there is some shade resistant capability within cells and within modules, but it's not perfect. I've had shading problems in my PV and I've had to move some panels to get around that. So yeah, the shading protection is there, but it's not perfect.
Just to comment on your comment, go for quality, I would argue that if you buy a system which is say 30% cheaper and replace it in 15 years' time, you'd still be ahead.
Yeah, it's hard to know whether it's going to last 15 years or 15 months. So.
Isn't there something about the matching of the panels though, that depending on the quality of the supplier as to whether you get panels that are all matched and therefore
work together?
It's a sort of second order consideration. Installers don't like to mix and match. So it'll still work if they're not matched, but it's not optimal. Yeah.
Last question from Bronwyn. Sorry, and we might. Are you?
Just a question on microinverters.
Sorry, next question over here.
It's just, I'm wondering if there's any benefit in having east and west facing panels. We've got shadow.
Yeah, there is. If you can do both, that's great. Then you get they complement one another, so you get more output for during the course of the day. So Yeah. So one of the BZD staff members recently put East and West on, and I recommended it was sort of 60-40, 60% west and 40% east, because arguably the output of the PV is more valuable on a hot summer's afternoon. So you sort of skew the balance towards the west. But you might decide that the winter morning was more valuable and put more on the east. It's a personal choice.
Better than doing that, better than that than having them face due north.
If you face due north, you get more yield over the course of a year, but it might be more valuable to you to have that yield during the course of every day be flat.
All right.
Okay.
Thank you.
Yeah, I think we're going to have to wrap up. I feel like we could go on for a few more hours, but
2 more years.
Thanks, Richard and James. That was really great. So usually after the discussion group, a few of us will head to the pub next door, and I think Richard's going tonight, so we can sort of carry on the discussion there. If anyone wants to come for a drink or dinner, I think the kitchen's open till 9 or something. Oh yeah, another plug for signing up for Energy Freedom.
And remember, put a success story if you're
Yeah, and spread the word with friends and family. Strangers you overhear complaining about their bills. Also, as I said, VCD is always looking for volunteers, but also always looking for donations to support the work we're doing. So thanks to everyone who's a baseload supporter. And if you're not, maybe consider becoming one. You can find out more on the website. Also on the website are YouTube recordings of the discussion groups and slides, so you can catch up on any that you've missed and rewatch tonight's. The next discussion group, so there's not one in April because it clashes with Easter. The next one will be in May, and speaker is yet to be confirmed, but watch this space.
Thanks,
so, yeah, thanks everyone for coming.